Today our topic is area of regular polygons, and our learning target is how can I find the area of regular polygons inscribed in circles. All right, so our key term is regular polygon. So a regular polygon is a polygon whose side lengths and angle measures are all the same, so it looks very symmetrical. All right, so a regular quadrilateral would be a square, because all four sides are equal and all four angles are equal. In this diagram, we have a regular polygon. It's a six-sided figure, so this would be a regular hexagon. The center of the polygon, right here, and the radius of the polygon are the center of the and the radius of the circle. So same piece here. So these are the radii of the circle. This is the center of the circle, so we also call it the radius and the center of the polygon. So just so you know those terms. Now the two radii that I drew in green, and then this one side of the polygon make an isosceles triangle. All right, so this is actually an isosceles triangle right there, because two sides are the same length because of our two radiuses. The distance from the center to any side of the polygon is called the apothem of the polygon. Okay, so that would be this piece right here, that height of that isosceles triangle. So that distance from the center to the side. It's called the apothem. Looks like apothem, but I did Google it, so I was pronouncing it right, and they told me it was apothem. So, however you want to say it. The apothem is the height to the base of an isosceles triangle that has two radii as its legs. So, just restating what I just said. A central angle of a regular polygon. So, I'm going to draw that here in black. So, that central angle would be this angle formed by two radii. Right there. It is an angle formed by two radii, drawn two consecutive vertices of the polygon. To find the measure of each central angle, divide 360 by the number of sides. So to find that angle, we would take 360 and divide it by the number of sides of a polygon. Well, we have 1, 2, 3, 4, 5, 6 sides to our polygon. So we would divide it by 6, and we would get that central measure is 60 degrees. All right, so all of these things we're going to need to be able to use and work with as we go. So make sure you understand what those vocabulary pieces are. Example 1. In the diagram, ABCDE is a regular pentagon. So pentagon is 5 sides, inscribed in circle F. Find each angle measure. The first measure we want to find is angle AFB. So angle AFB would be this central angle right there. So remember, that's the angle that we do 360 divided by the total number of sides. Well, we have 5 sides, so we're going to do 360 divided by 5, which gives us 72. So this is equal to 72 degrees. Letter B, the measure of angle AFG. So AFG would be this angle right here. Now the cool piece about the apothem, which is this blue line, if you remember from the vocabulary, is it actually bisects that angle. So these two angles that I've drawn in red are actually going to be equal to each other. They're going to be congruent, and they're going to be half of that total angle. So what we have to do is take 72, divide it by 2, and we get the measure of that angle, which would be 36. So AFG would be 36 degrees. All right, and then the last one is we want the measure of angle GAF. So GAF would be right here. And then we can just use the fact that that's part of a right triangle. So I draw that triangle right there. We got the right angle. This angle AFG was equal to 36 degrees. We know that a right angle is 90 degrees, so we can find the measure right here of angle GAF by adding 90 and 360, or 36, and that gives us 126, and then if we subtract that from 180, the total degrees of a triangle, we'll get our measure of our angle, which is 54. So this is equal to 54 degrees. Last piece, the big takeaway, is theorem 11.11, area of a regular polygon. So the area of a regular n-gon with side length S is half the product of the apothem A and the perimeter P. So our area formula is half times A times P, or area equals half times A times NS, because our perimeter formula is actually N times S. So the number of sides times the side length. So in our example, we want a regular nonagon is inscribed in a circle with radius 4. Find the perimeter and the area of the nonagon. So first off, we just want to find all those different pieces. So we want to solve for our A, we want to solve for our N, our number of sides, and we want to solve for S, our side length. Once we have that, then we can focus on finding the perimeter and then the area. So one of these is really easy. The N, the number of sides. We're working with a nonagon, which means it's a 9-sided figure. So N is going to be 9 because we have 9 sides. A and S require a little bit more work. So if we take a look at our diagram, our side length, I'm going to draw here in blue. That's going to be KJ. So I can write that on the side here. And then the apothem, I'm going to draw here in red. That's going to be from the center of our circle to point M. So just color over it in red. So you remember it's the red piece. All right. So we're going to have to use the fact that we're working here with a right triangle, and also that these two pieces are equal because our apothem bisects the side. So it cuts it in half. So I'm going to redraw just one of those right triangles right here. And I would recommend you do 2 on your paper. So we'll do LKM. All right. So this side is our red side, our apothem. So I'm going to put an A there. And then the blue piece is half of our side length. So I'm just going to call that X for now. We also know that this is 4. We need to know what this angle is, and we are able to do that by finding the central angle and then cutting it in half. So remember, to find that central angle, we do 360 divided by the number of sides, which is 9. And then that's going to give us 40 degrees. So the central angle is 40 degrees, and then half of that would be 20. So both of those halves are 20 degrees. So right here, this is 20 degrees. Now we need that angle because to find our side length X and to find our apothem, we are going to have to use SOHCAHTOA. Use those trig ratios. So the first one, if we want to find X, we look at our angle, 20 degrees. This is the side opposite. Our A is our adjacent, and then 4 is our hypotenuse. So if we want to find X, we're going to need to use sine because we need our opposite and our hypotenuse. So we can say that the sine of our 20-degree angle is equal to the opposite side X over our hypotenuse 4. Solve for X by multiplying both sides by 4, and we get 4 times the sine of 20 is equal to X. Use your calculator to get an approximation for X, and we get 1.37. Now, 1.37 is 1/2 of the side length. So to find our side length, we're going to need to do 1.37 times 2, which is going to give us 2.74. So our side length is 2.74. We know our number of sides is 9. Now we just need to find our apothem, which again we're going to need to use this right triangle that we drew. Except for now we're looking for that adjacent side. So to do that, we're going to need to use our cosine ratio. So cosine of 20 is equal to our adjacent side A over our hypotenuse 4. Multiply both sides by 4 to get a by itself. And we get 4 cosine 20 is equal to a. Use your calculator to get an approximation for a, and that's going to be 3.76. So now that we have all of our pieces, we can find our area and our perimeter. So perimeter formula is n times s. So we do perimeter is equal to 9 times 2.74. So our perimeter is 24.66 units. Last is our area, and then our area formula is 1/2 times A times P. So A is our apothem, which if we look was 3.76 times our perimeter, which is right there, 24.66. Do the multiplication, we get that our area is equal to 46.36 units squared. All right, that's all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.